Okay, so let's finish for real chapter 6. Okay, we're going to start off with this word problem. It says Kay, Paul, and Judy made $2,520 painting a house. The money will be distributed in the proportion of the hours that they worked. Kay worked 30 hours, Paul worked 50 hours, Judy worked 60 hours. If they all make the same rate, how much did each earn? So first let's just show our, sorry, let me get my pen going here, show what our proportions are here. Well, we've got 30 to 50 to 60 if we wanted to write those out like a proportion. And remember, with proportions, you can multiply through by the same number, divide through by the same number, as long as it's the same number, and we can change this. So this is actually equal to the same proportion, right? The same thing. Okay, well, that's just a little side note. Let's get to solving this problem. So for us to solve this particular problem here, they all make the same rate. And since they all make the same rate, we can let x equal whatever that rate is. Okay? So we're going to write an equation here, and the equation is going to be the number of hours each person works times whatever that rate's going to be. And that's going to all be equal to 2,520, the total amount of money that they're going to earn for the job. Okay? So now let's just put this together. We have 140x is equal to 2,520. When we divide by 140, we get x is equal to 18. So they're going to make $18 an hour. Now, it's always good, and you want to emphasize this to your students, to go back to the word problem when you think you're done and read it and make sure you got all the components. Now, we figured out how much we need, how much they're going to make per hour, but we also need to find out how much did each of them earn. That's really the question here. So let's figure that out. So Kay, well, she did 30 hours at $18 an hour, and that is $540. And Paul, he did 50 hours at $18 an hour, and that's $980. Sorry. And then we have Judy. And Judy worked 60 hours at $18 an hour and made $1,080. Okay? All right. So let's hit up a couple of theorems here. The first theorem says for any two rational numbers a over b and c over d, where a is not equal to 0 and c is not equal to 0, the proportion a over b equals c over d is true if and only if b over a is equal to d over c. Do you see what happened there? We flipped both of those over, okay? Remember that here we just found the inverse. So that's b over a and d over c. All right, so it says that this is true if and only if two proportions are equal to each other, if and only if they're equal to each other if you flip them upside down. Okay, these are existence theorems. They're not really theorems we'll do much work with, but they're theorems that back up the fact that if we write a proportion one way, we can flip it over if we want to make it easier to solve, so the variable maybe is not on the bottom. So there's some reasons why you want to do that, and this is just the theorems that back it up. Okay, the other theorem that goes along with this is the same idea, except for here you notice that the B and the C are changing direction. Now, this might be a little bit perplexing, and it might kind of seem like, how is that the same? But let's just check it out. We're going to check it out by doing some cross multiplication. Remember that proportions, we can do cross multiplication. So here, A times D is AD equal to B times C is BC. So if we do this guy here, we have B times C, which is BC, is equal to A times D, which is AD, and we know that these are equivalent. And that is the same as that, so let's check these two here. So this one gives me B times C is equal to A times D, also equivalent. So that is true. As long as you've got your proportions going on, right, we can kind of move some things around within that proportion without changing what the answer is to the proportion. All right, let's move on here. Let's talk about bar models for ratios. I don't know why I said rations. That should be ratios. Let me, I missed that. Ratios. Not rations, ratios. Okay, so let's take a look at this scenario here. Let's model having 6 red boxes and 5 blue boxes. Okay, well 6 plus 5 is 11, so I have 11 boxes here. So it looks like we'll have 6 red and 5 blue. Now this is showing a ratio or a proportion that is part to whole. Okay, so we could get a lot of proportions here. So if we wanted to say the proportion from red to blue, the proportion of red to blue is 6 to 5. How about the proportion of red to boxes? That would be 6 to 11 because there's a total of 11 boxes. How about the proportion of blue to red? The proportion of blue to red would be 5 is to 6. And then we might as well just round it out here. Blue to boxes. That would be 5 to 11. Okay, and of course all of these ratios could also be written in fraction form, so don't forget about that. So the comparison model here is a little bit different. We look at the entire thing as the whole. Wait, I lost my pen. And one side is going to show the part for the red, and the other side is going to show the part for the blue. That is so sloppy. But anyway, doesn't feel quite as useful as maybe the part to whole model, but it can be very useful when comparing if the sizes are the same, like if 2 to 3 is the same as 4 to 6. So something like that could be helpful for that. Okay, let's take a look at our next example. In third period Spanish class, the ratio of girls to boys is 3 to 2. If there are 8 boys in the class, how many girls are there? Now, one thing that I do, and I still do, is I like to notate, you know, what each one of these numbers, who each one of these numbers represents. So I'm going to write here a G to B, so I know that that's girls to boys, okay? And we know it's the ratio of girls to boys because it was described to us right here. Okay, so let's model that real quick. So girls to boys, that means if it's 3 girls to 2 boys, then we could call this a girl, this a girl, this a girl, and that would make this guy a boy and this guy a boy. So that's our basic model for the ratio of girls to boys. It goes on to say that there are 8 boys in the class. Now this model is super helpful. I mean, I find it pretty clever. So what it means is that this portion right here is equal to 8. Well, there are 2 units here. So if we divide that 8 by 2, then it's 4 each. So basically each block here stands for 4 students. So how many girls are there? Well, we could do this problem a couple of different ways. First, we could just straight up count them, right? 4 plus 4 plus 4, which is also 4 times 3. That's probably the easiest way, which is 12. Okay. All right. The ratio of 8th graders to 7th graders is 4 to 7 at a student club meeting. Now we're going to answer some questions here. The first part of the question says, if a quarter of the 8th graders are boys and 2/7 of the 7th graders are boys, what's the ratio of boys to students at the club meeting? Now, we need to first model our first ratio. I want you to notice here that we actually have 3 ratios. We have the original ratio, which is that the ratio of the student class mix at the meeting is 4 to 7. So let's take a look at that first. So here we've got 4 for 8th grade, and we've got 7 for 7th grade. So this is a good model, a good representation of how the boys and the girls break out. Okay? So now we need to model again our 8th graders and our 7th graders. So our 8th graders are actually in green over here with the 8. So how do we show a quarter of the 8th graders? Well, I'm going to color up a quarter of the 8th graders. Okay? And now when we turn to the 7th graders, it says 2 out of 7 of the 7th graders are boys. And we can put this together in either place. We could color them here, or we can start down here at the end. We could pick them up anywhere in the middle. I kind of like to meet them in the middle. It makes it pretty nice visual here. Now, let me make sure that you see what I have here. So from here to here, that's modeling 1/4, right? And from here to here, this is modeling 2/7. Okay? So, it says, what's the ratio of boys to students? Well, we have 3 boys and it's not to girls, and it's not to 8th graders, and it's not to 7th graders, it's to students. And how many students, how many groups of students do we have? We have a total of 11 groups of students. Now, just for fun, what would the ratio of girls to boys be? Well, we have 3 boys, so that's going to have to go on this side. And how many girls then? Well, if you're not boy, you're girl. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 to 3 girls to boys at the club meeting. And then let's answer this question. If there were 9 boys at the meeting, how many total students are at the meeting? Well, here what we're going to do is we're going to use the idea that we know there were 3 groups of boys. So that means that these 3 groups of boys was actually 9 boys. And if that was 9 boys, and we divide it by the 3, and let me call them units, the 3 units, then we actually have 3 per unit. Okay. All right. So we know we have 3 per unit. And we have 11 units times the 3 per unit is going to give us 33 total students. All right. Okay. Another example here that's completely different, but still using the bar model. Roberto, Andrew, and Josh all have candy. And the candy that they have is in the ratio of 4, 5, and 7 respectively. Meaning Roberto's got quantity of 4. If they only had 1 piece, Roberto would have 4, Andrew would have 5, and Josh would have 7. Okay, but those can all be ramped up to whatever degree it is. Josh has 21 more pieces than Roberto. How many pieces does each person have? Okay, so using a bar graph is really, really helpful here. And one thing that you need to note is that Roberto has 4 and Josh has 7. And so Josh has this many more than Roberto. Okay, let me make sure you see. Here's all of Roberto's squares. And if I mark off the same squares 1 for 1 with Roberto, then you can see we've got 3 extra squares. Well, we know that Josh has 21 more pieces than Roberto. So this is equal to 21 pieces. And just like the last example, we can divide those 21 pieces by the 3 units that we have to find out how many pieces per unit. And that means that we have 7 pieces per that unit. Okay, and so how many pieces did everyone have? Well, Roberto had 4 times 7, which is 28 pieces. Andrew had 5 times 7, so he had 35 pieces. And Josh had 7 times 7, so he came in with 49 pieces. All right. The more you work with the bar graphs, the easier they get, and the more effective a tool they actually are. Let's take a look at this last example here. The ratio of men to women at a party was 5 to 2. So before I get any further, I'm going to declare that this is men to women. And the ratio order doesn't change here, so men to women. So the ratio of men to women at a party was 5 to 2 before 14 more women arrived. At that point, the new ratio became 4 to 3. How many men and how many women were at the party? Seems like it's a pretty non-related question, but actually we're going to be able to solve it pretty nicely here. Okay, so let's get our men and our women designated here. So we had 5 men, or 5 units of men, to our 2 units of women. Okay, and now I'm going to model that exact same thing here. But remember now, the idea with the bar graphs is that these 2 bottom graphs have to be the same length and the units get shifted. Okay, so for bar graphs to really work with this idea, you have to deal with the same length here. Obviously, this one, and then we're going to increase by 14, so the length has to change here for that plus 14 women. Okay, let me throw my other women here, and let me put our men here, because we didn't change the number of men, we just added these 14 women, and now what we have is the ratio has changed to where there are 4 men and there are 3 groups of women. That's what all of that meant. It meant start off like this, model what happens here, model the plus 14. When you model the plus 14, these 2 must be the same size. And the size of the units change. Okay, it's kind of subtle. I probably should have made this a little bit bigger, but it's subtle. But you can see where we added the 14 women from here to here because we added length there, and then when I made this, I made sure that my 4 to 3 was the same length as my 5 to 2 plus 14. Okay, so hopefully you understand where all this is. Now, how in the heck are we going to use this? That's really the big question, right? Okay, well, let's make some observations here. Okay, and I'm going to call this the original, and I'm going to call this the new. So this is the original units, and this are the new units. And we know that the units change because we see that the size changes, right? These are smaller than those. Okay, so, and that makes sense because even though we still have the ratio of 5 plus 2 is 7 and 4 plus 3 is 7, the unit spans, the number of people in the unit have gotten bigger. Okay, so we're going to make this first observation that's going to might be a little hard to follow what I mean here. So, but for the men, 5 original units I totally cannot spell original right this minute. Original units are equal to 4 for new units. And let me show you again how you can see that, because it is super subtle. So I'm going to kind of draw this line from here where they split, right? And if I could draw a straight line, you'd see that that's true. There's 5 here, 5 originals, and now it's 4 new ones. So that's how I got this equation. And that's for the men. So what is it for the women? It's 2 plus 14. Well, 2 originals plus 14 is really how I should write it there. Sorry, let me write it correctly. 2 originals plus 14 is equal to, and what was that equal to? It was equal to 3 news. And it probably would have been better if I had talked about these being the 5 original than that original one. But notice that these are exactly the same and they did not change. I already had stuff written there, so I didn't want to write over myself. But anyway. Okay. And so that is equal to 3 new units, right? Because that's what we see here. 2 original plus 14 is equal to 3 new. Now, we're going to use kind of an algebra trick. And the algebra trick is we're just going to add these guys together and see what happens. Okay, so let's add them together. And so we get 7 original, because we can only add like things, plus this 14 is equal to 7 news. Oh, well, that's good. That kind of seems like we're getting to where we could bring that down to, say, the simplest form here. So in simplest form, which means you just want to simplify it, if we divide by 7, everything by 7, we wind up with 1 original plus 2 is equal to 1 new. Ah, we're getting closer to figuring this out. Okay, now we kind of need to know how to relate the 4 news to the 5 originals. That's really what we want to kind of do. So since we can multiply or divide by any number here, I'm going to multiply this by 4. So that means I'd have 4 original plus 8 is equal to 4 new. Now this interests me because we know that 4 new is also equal to an original. Now check this out. This is something I need to point out. These are different variables, and we can't solve this equation with 2 different variables. We need some way to get the same variable. And what we know is 4 news equals 5 originals. We know that right here. 4 news equals 5 originals. Okay? So we've now gotten this equation written so that we can replace that 4 new. And so we'll have this. Let me write the left-hand side of the equation down. 4 original plus 8 is equal to, and now that 4 new right there, I'm going to rewrite as 5 original. Now we have the same variables. And we can add those things together, move them from one side of the equation to the other, and all of that business. So if I subtract this 4 originals from both sides, I'm going to get the equation of 8 is equal to 1 original. Yay! Now we know. Now we know. So each unit is equal to 8 people. And so how many men and how many women? Well, the way I figured it out, here I'm going to put it in a little bubble. I knew I was going to be pushing the limit with this question, but I didn't want it to go over two slides. Okay, so how do I figure it out? Well, we know 5 to 2 for sure because that was given in the question. So I'm literally going to go 5 times 8. Right? That's how many men we have. So 5 times 8 men, which is 40. And 2 times 8 women, which was 16. That gave us 56. Plus our additional 14 women gives us 70. So up here I'll say the total at the party was 70 people. Okay, well, I hope you enjoy learning some stuff about proportional reasoning. I really like it because it's really something you can actually use in your everyday life if you're trying to figure out stuff. So proportional reasoning is a good deal. Okay, well, I hope you guys have a good day. Thanks. Am I all right?